everyone, welcome back to Build, Create and Learn a Maker's Journey. I'm your host Stefan, and today's story is a mix of wins, frustrations and a big decision that I think will shape how I work on this drone telemetry project and maybe even how I approach projects in general. If you have been following it along, you know I'm building a telemetry system for my FPV drone. The idea is simple enough. Log environmental reading and GPS position during flight, so I can analyze them later. In the last episode we finally got GPS data flowing. The next step sounds straightforward, passing the data and then saving it to an SD card. Of course, that's not exactly how things went. Part 1. A solid win. My GPS parser works. Let's start with the good news, because there was some. I got my GPS parser working, and it's actually doing exactly what I want. Right now I'm passing two specific NMEA sentence types, RMC and GGA. If you're new to GPS data, NMEA sentences are lines of text that the GPS model sends out, usually every second. Think of them as little status reports. GGA is a global position system fixed data. It tells you things like the exact time, your latitude and longitude, the quality of the GPS fix, how many satellites are logged in, and your altitude. RMC is recommended minimum navigation information. That's where you get your time, position, speed over ground, and heading. Between these two, you basically have all the core information needed for a flight log. Where you were, when you were there, and how you were moving. I also added a motion threshold to the code, so the system only logs when you're actually moving. This helps filters out little jumps and wobbles GPS can sometimes report when you're standing still. And here's another win. I tested my new external active GPS antenna, and the difference was night and day. With the internal antenna, my readings were constantly about 160 meters off from the actual position. With the external antenna, the offset was gone, and I had a solid fix with at least 5 satellites. I still had to be near a window, but the accuracy was exactly where I wanted it to be. These moments when something actually works better than you expected are what keeps you going on projects like this. Part 2. The SD card saga. Now for the part that didn't go so smoothly, logging the data on the SD card. I'm using a Seed Studio Arduino SD card shield. On paper it's simple, plug it in, talk to it over SPI, that's the Serial Peripheral Interface bus, and start saving files. In reality, nothing worked. I started with the most obvious setup, mounting the shield directly on the Arduino compatible socket on my STM32 development board. That's when I realized it was expecting to use the SPI1, but SPI1 on my board was already tied up by the onboard LED and the SWD debug port. Quick beginner note, SPI is like a little high-speed data highway that lets your microcontroller talk to peripherals like SD cards. But you only have so many lanes and exits, and if one's already taken, you can't just plop another device onto it without causing a traffic jam. So I tried using jumper wires to connect the shield to different pins. Still no luck. Then I decided to move everything to SPI2 and put the shield back directly onto the board. Nope. At this point I was suspicious of everything. Maybe the other sensors, GPS, BME 280, were interfering, maybe my code was too messy. So I stripped the setup down to just the SD card and the microcontroller, started a brand new project in the IDE with minimal code and still nothing. I went through every possible culprit. Voltage mismatch, was it a 5 volt versus 3.3 volt or logic level thing? Flaky chip select pin? Noisy power? Wrong SPI mode, clock mismatch, some obscure library incompatibility. It could have been any one of them, or worse, a combination of several. Part 3. When the code isn't yours. Here's the truth. I can write some C and C++, but with this project I've been heavily relying on ChatGPT to generate some example codes. And that's fine, until something goes wrong. When the code didn't work, I often wasn't confident enough in C to know the right next debugging step. That's a tough place to be in, because instead of making informed changes, I was just throwing ideas at the wall and see what stuck. In Python, I know the syntax, I know the libraries, and I can debug efficiently. In C, I was spending most of my mental energy just trying to understand the code in front of me, not solving the actual problem. And then it hit me. I was on the verge of turning this fun experimental build into a tedious grind. And I have been there before. Shelves full of projects that are 80% done but never finished because the fun got replaced by frustration. Part 4. The Maker's Pivot. That's when I revisited MicroPython and CircuitPython. For those who haven't heard of them, they are versions of Python that run directly on microcontrollers. They are slower than C, sure, but they are much easier to work with if you already know Python, and especially in the prototyping phase. And I know Python. I've built web apps, APIs and data pipelines, even some automation scripts for my workshop. I'm comfortable there. And when I looked into CircuitPython's library ecosystem, I saw ready-to-use, well-documented modules for my GPS, for my BME 280 and yes, for an SD card. So I made the call. I'm switching to CircuitPython. Not because I gave up on C, but because I wanted to finish this project. I'm not building a flight computer for a commercial airliner, I'm building a maker's prototype. My goal is to prove the concept, test it in the air, and move on to the next idea. If I ever needed the absolute fastest, most memory efficient version, I can always rewrite critical parts in C later. Part 5. New hardware, new energy. Once I made that decision, the hardware choice becomes obvious. The STM32 board is great, but it's not exactly designed for CircuitPython. So I ordered an Adafruit Feather RP2040, a small, efficient, Python-friendly board with great documentation. While browsing, I've found the Adafruit Feather RP2040 ADA logger, basically my dream telemetry board completed with built-in micro SD support. Naturally, it's out of stock, but just knowing it exists confirms my approach makes sense. I also ordered an Adafruit SD breakout board that's known to play nicely with CircuitPython. If this works, I will be back there where I wanted to be weeks ago, but without fighting the language the whole way. Part 6. Thinking about the build. There is another decision upcoming. How to package the prototype for testing. I could keep it on a breadboard, throw it into an enclosure and call it a day. Or I could try solder it to a protoboard, or even design my own PCB. Even if the PCB isn't perfect, it would be an amazing learning experience. And here's the practical side of it. Since I still plan to test my device on a drone under real conditions, it needs to be stable and mounted well. I don't think the breadboard in an enclosure will be a good solution here. Vibrations, loose wires and sudden landings, all of that can ruin a test flight if the hardware isn't locked down. Designing a PCB feels intimidating, but I know it would force me to think more carefully about the layout, connections and long-term durability. It would also open up skills I could reuse for future projects. Part 7. The bigger reflection. Here's the bigger lesson I'm taking away. Choosing the right tool for your style is not cheating, it's smart. For years I thought pushing through with the hard tool made me a better maker. But the truth is, making isn't about suffering through the process, it's about finishing, learning and moving on to the next challenge, with more skills than you had before. This decision to switching is about momentum. It's about keeping the project fun and engaging, because that's what fuels creativity. If I'm dreading every work session, the project dies. If I'm excited to sit down and make progress, it lives. And maybe that's the part of the maker's mindset we don't talk about enough. It's not just about problem solving in a technical sense, it's problem solving in how we approach projects. Knowing when to pivot is just as valuable as knowing how to solder or code. Part 8. What's next? Before the next episode, my plan is to first set up CircuitPython on the RP2040, second, reconnect the BME 280 and GPS sensor, and third, trying SD login again with the new breakout board. Best case, I will have a fully working prototype logging both GPS and environmental data. Worst case, I will have at least a new platform that feels like a natural extension of my skills, one I can debug without headaches. After that, I will start thinking seriously about the physical design, whether it's a proto board build or my first custom PCB. The goal will be the same, a stable, flight-ready telemetry unit. Part 9. Closing thoughts. So, that's where I'm at. 2 weeks of mixed results. One working GPS parser, one stubborn SD card, and one big decision that I think will save the project. I'm leaving the frustration behind and leaning into a language and workflow that I know will let me keep moving. If you have ever had to make a hard pivot in a project, whether it's changing tools, materials, or even the end goal, I would love to hear about it. Drop me a message, connect on social, or please leave a comment. If you like hearing about my project, you will love the Maker's Logbook, a weekly behind-the-scene email newsletter. Thanks for listening to Build, Create and Learn a Maker's Journey. And if you enjoy following along the ups and downs, the aha moments, please subscribe wherever you get this podcast. Let's keep building, creating and learning together.